Welcome to today's lunchtime talk. This one is actually our first to be looking at the topic of material selection for retrofit, which becomes particularly important when you're retrofitting solid wall construction homes. So we're looking at kind of pre-1920s or thereabouts. Couple of housekeeping notes to begin with. If you can keep yourselves on mute, you should be on mute as you arrive, but could you keep yourselves on mute unless you're invited to speak? That will make things a lot easier. You may want to consider turning your cameras off as well, just because that will help us with the recording. You should know that we are recording today. You should have had a message saying that, but the whole of this event is being recorded and it will be shared with you and made available after. The format's going to be around half an hour of presentation, followed by a Q&A after that. Could you add your questions into the chat function? That's how we'll gather your questions. We'll be reviewing those. My colleague, Tony Baker from March's Energy Agency, he'll be keeping an eye on them and we'll be sharing them with Simon at the very end. So that's how we're going to work it. Right. Here we go. So I'm Gemma Hartley. I'm here with Building Sense, which is a Herefordshire Green Network initiative started in 2020 that brings together people, information and professional expertise to help with the challenge of making homes comfortable all year round in the face of high heating bills and of course cutting carbon emissions. Today we're delighted to be hosting Simon Ayres' presentation on behalf of the Future Ready Homes programme. Move on. Oh, sorry, just bear with me a moment. Here we go. So Future Ready Homes is a programme that's running in Shropshire, Ayres and Herefordshire. It's being delivered by March's Energy Agency and 7Y Energy Agency with the support of groups such as us, Herefordshire Green Network, Lightfoot in Ayres and Zero Carbon Shropshire in Shropshire. The main focus of the programme is to promote and support good practice energy retrofit of homes across the whole of the Marches area. And part of it is providing a number of free energy surveys and retrofit plans. The scheme is looking for a really good cross-section of building types for those free surveys. So not everyone who applies will get the free survey. However, right now in Herefordshire, there are a significant number of additional free surveys and retrofit plans available, making it a really good time to apply. And most of those need to be delivered by the end of March. So if you are in Herefordshire and you are concerned about your property and you would like to consider retrofitting, please apply to the programme. We'll share more details about that after there's a follow-up. So let me introduce you to Simon. Simon Ayres has been working with and selling lime mortars and plasters since the late 90s, when he worked as a repairer and builder on a wide range of historic buildings. He's got a genuine passion for quality, environmentally friendly products, and they weren't readily available at that time in the UK. So Shropshire-based Lime Green Products was founded in 2002 to meet that need. Since then, Lime Green has set about developing and manufacturing a wide range of lime-based products, everything from mortars, renders and plasters to wall insulation, all of which are natural, sustainable and energy efficient. Simon has considerable technical expertise in the field, and luckily for us and all of you, he's more than happy to offer technical and practical advice to homeowners, building and restoration companies all across the UK. And obviously locally as well. So Simon, would you like to take over, please?
Yes, thank you, Gemma. Hello, everyone. I will share my screen if I remember how to do it. Oh. So hopefully everyone can see that. As Gemma said, I'm Simon from Lime Green. We've been making and selling lime plasters, mortars and that sort of thing for a number of years. And in the last 10 years, we've spent quite a bit more time focusing on insulation systems. And I'll talk a little bit more about those in a moment. But those insulation systems we generally describe as breathable. And that works nicely with the breathable line, but I'll explain in a moment. Okay, so you may already know this, or I don't suppose it comes as a huge surprise, that approximately a third of the UK homes are energy inefficient, cold and damp potentially, and therefore have a large carbon footprint. Especially at the moment, this winter is true that it's increasingly expensive in terms of heating them. And obviously there's a knock-on effect for those energy efficient homes for the environment, because a lot of income is diverted towards heating, and also there are knock-on effects with the health of the occupants of those buildings as well. So as it says there, 27% of the UK's carbon emissions come from residential housing, and that's something we all need to address and think about. So the insulation that we primarily deal in and supply and know most about is internal and external wall insulation. And again, primarily, but not in all cases, a lot of that is aimed at what are called solid wall buildings. So solid wall buildings are buildings where there is no cavity in the wall. So a modern house, they'll be generally built with a cavity to protect us against moisture and wind-driven rain and that sort of thing. Older houses, those approximately more than 100 years old, are called solid wall, built with a solid wall. There's around about 9 million of them, very approximately. And of those 9 million buildings, the majority, but not all, were built with lime. Cement was invented in early 1800s, but it wasn't really used for all uses until 1930s or later. These buildings are perhaps best described as buildings of vapor permeable construction, or breathable, in other words. So generally described as breathable. So solid wall buildings, how do you identify them? Well, stone wall, that's fairly straightforward. Almost all stone buildings are solid walled. Brick built buildings, there's often this telltale way of identifying what's a solid wall brick building, because you've got what are called the headers. So these that brick there circled in the middle, that's the brick that ties the two leaves of wall together effectively. So the bond or the brick pattern that you see on the outside is often a telltale way of figuring out if you've got a solid wall or not. So having to determine whether you've got a solid wall or not, I mean, more modern houses will need insulating as well, but as I say, we mainly focus on older ones. And the consideration for all retrofit insulation is, whether it be external or internal, you have to weigh up a number of things, and the three fundamental ones are, the thermal considerations, the risks associated with adding insulation to an old building or older building. Older buildings weren't designed to be insulated, and so by adding or changing them fundamentally, the building physics change, so there are risks are introduced. And then there's the spatial considerations like if I add insulation on the outside of my wall, I keep all the space on the inside, but have I encroached on the neighbour? Have I encroached on the footpath, or these sort of things? So there's the sort of the practical nature of it. So insulating externally, it is the more efficient of the two means of externally insulating a wall. If you think of it a little bit like a tea cosy, it envelops the whole house, and it does a better job of cutting thermal bridges. Thermal bridges being bits of the wall which are difficult to insulate. So I'll come on to that a little bit later on as well. Drawbacks, it can change the appearance of a building, particularly if a building obviously isn't rendered or in the first place. Adding external insulation. External insulation is mostly rendered, the finish. It can be timber clad, it can be clad in other materials as well, but it's usually rendered. So if a building is unrendered at the moment, adding in external insulation will definitely change the appearance. The detailing, adding insulation to the outside of the wall, you're growing the footprint of the building. And so the water detailing, things like the roof, things like sort of thing you won't think about, but downpipes, roofs, what happens at the bottom of the wall, junctions with chimneys, all those sort of things, they've got to be taken care of. You will obviously also potentially lose period details if it's unrendered at the moment. And it might be difficult to change the appearance of a building if it's a listed or protected building in some way. So the reasons for doing it over internal insulation, it's thermally more efficient, and thermal bridges are sort of where heat can get past the insulation, if you like. And with external insulation, because it's got that tea cosy effect over the whole building, it does a better job of cutting those thermal bridges. As I mentioned, there's no loss of space inside the house or building, and the risk of condensation occurring within the walls, so the existing walls, is lower. It's not zero, but it is lower. It also gives the opportunity to improve the weather defence of the building, because you're adding another layer over the top effectively. Internal insulation, for and against, complex dealing inside. So the reveals, intersecting walls and floor zones, they're the difficult bits to insulate, and they end up being thermal bridges or areas where heat can bypass the insulation. And doing it internally, if you have an example, might be a staircase that runs parallel with an external wall, you can't fit insulation between the staircase and the wall. You might, just like outside, you might lose period features, things you want to keep, or you might end up hiding them because they're hidden behind the insulation. It is riskier from a condensation point of view. That building physics thing kicks in again, and when you insulate internally, there is more risk of moisture occurring within the wall. I'm going to speak about this a little bit later, and its relation to natural insulations. Because of the thermal bridging, as mentioned, you can add exactly the same thickness of insulation inside or out. When inside, because of those thermal bridges, you get a lower performance. You lose some space, though it's not quite as much using the sort of system we recommend as you might think. Obviously, if things going for it, you get to keep the outside of the building looking as it always has. It's generally cheaper to do, and you can also do it room by room if you like, which also can lessen the cost. I think it is an easier thing to install, partly because it doesn't all have to be done at once. It's broken up into chunks, whereas external installation is you have to do the whole thing at once, essentially. Here's a nice picture of just to amuse you, of external installation on the right, obviously, and what it can do to the appearance of an old building. Something quite dramatic. It doesn't have to look like that, and I'll show you some examples later of why it doesn't have to look like that. Okay, types of insulation that you might use for either internal or external. Basically fall into two main categories. Those that are synthetic, and they might include expanded polystyrene, extruded polystyrene or foam products, thermoset foam products, and the inorganic. So inorganic, they're organic. Inorganic would be mineral wool, foamed glass, things based upon mineral and things like that. So there's pros and cons to all types of insulation. I'll comment on those a little bit later on. Natural insulation would include things like wood fibre, that could be flexible or rigid, straw, sheep's wool, which is generally flexible, products like hempcrete. But in general, these are all materials that are biogenic, or materials that are grown. So they are essentially renewable. If you want to look into this a little bit further, we are a member of the ASBP, Alliance for Sustainable Building Products, and they've got some really useful guides on all sorts of different topics, and their 6 pillars of sustainable construction kind of follows through for when you're choosing your materials. So these speak for themselves more or less, but health and well-being, how does the material affect your health and well-being, the resources used to make the material, the embodied carbon in it, the ethics and the transparency of the company or companies making it or supplying it, its technical performance, obviously very important, and social value. So you can go to the ASBP website, and lots of stuff on there, and lots of useful information too. So we think it's important to think about it with the ASBP's 6 pillars in mind, the multiple roles of insulation. Obviously, insulation, we also know insulation as the material that saves us heat, but actually it's more than that. There are other things which perhaps are, to a greater or lesser extent, just as important, such as acoustic. You can use insulation to insulate against noise. Some insulations naturally have good acoustic and thermal performance. An example would be a wood fibre board. Fire protection, health, comfort, buildability, durability, and sustainability. So there's quite a cross-section there. Fire protection kind of speaks for itself. If you're buying a system or installing a system, the manufacturer or reputable manufacturer will have fire tested the system rather than just the products. And health, well, I'll speak about this in a moment, but health is obviously very important. It's in the news at the moment about the health or the poor health of people who are living in buildings which are damp and mouldy. Comfort, that kind of rolls into some of the others as well. Buildability, we think this is important. You know, products used should be easy to use, shouldn't be mysterious, and require some sort of special voodoo to use them. And durability speaks for itself. We like to make sure that our systems are fully tried and tested. For example, if you're buying an external wall insulation system off almost any company, they will have had to pass durability tests. So the system may or may not have third-party accreditation, but behind that third-party accreditation will be a set of tests for things like impact resistance, freeze thaw, how breathable it is, how weather resistant it is, and that sort of thing. Then obviously the last one, sustainability, goes back to those points from the ASBB. So natural insulations, they offer thermal performance with added benefits. They're not just a one-trick pony. They, in particular, the thing they do really well, many of them, and particular wood fibre, which I'm speaking mostly about today, is moisture regulation. And that has a huge knock-on effect for indoor air quality and the longevity or the durability of the structure, and therefore of the retrofit. Specific heat capacity is less important with wall insulation unless it's a timber frame, but some insulations have the ability to reduce or dampen the effects of summer heat, whereas others are not very good at it at all. So generally speaking, lightweight insulations, particularly in an attic space, you might be familiar with this, can really heat up the attic. It might be well insulated, but it can heat up in the summer and overheat. Already mentioned this, wood fibre, very good at dealing with moisture. It can absorb, store and release it without affecting the thermal performance. Sheep's wool is also good in that regard. Natural insulations, generally speaking, lock up carbon and then release at the end of their lifespan, whereas synthetic insulations generally release carbon on their manufacture and also when they're at the end of the lifetime. Increasingly, partly because of the rising costs of petrochemical-based materials, natural insulations are increasingly becoming a commercial alternative. So they offer technical benefits and carbon benefits, but also up until recently they were always quite a bit more expensive, but now that's becoming much closer, and they are a realistic alternative. It's also worth pointing out that lime, plaster and wood fibre are the recommended technical answer for internal insulation. So if you go to the government's best practice guide for retrofit internal insulation from Bayes, their best answer is to use wood fibres from a technical point of view. Here's a nice little Christmas tree, almost, if you like, of embodied carbon in different materials. It's a really neat pyramid from a Danish website. So you can see the website there at the bottom. Just thought I'd show you this because it's quite interesting. At the top, you've got the materials with the highest embodied carbon there is, and it's things like aluminium sheet, copper, zinc, those type of materials. Coming down, you've got things like ceramic tiles, roof tiles, plastic membranes and so on and so forth. The one there, I've put the arrow at the top, you've got a very common used insulation given off in its production per cubic metre, so over 700 kilograms cubic metre. Bricks and fired materials and concrete and that sort of thing are beneath that. And then the next one there, EPS, that's expanded polystyrene. That's considerably better than PIR in terms of carbon released in its manufacture. It's only 80 kilograms of CO2. And then beneath that, you've got the sort of the biogenic type materials. So basically those made from wood or flax or hemp or those sort of materials that are grown. And as an example there, you've got wood fibre insulation. It depends exactly on the brand and where it comes from, but around about it locks up 200 kilograms of carbon per cubic metre. So huge difference over different materials. There is a difference in thermal performance and other aspects, but in terms of carbon released during its manufacture, you can use the website there to have, it's got a little calculator if you want to play around with things and work it out for yourself. So thermal values, going back to that wheel at the beginning, thermal, spatial and risks. U values are the things we use to measure how efficient or calculate how efficient a particular measure might be. So a U value is a calculation that's used to signify how well the building, so an element of the and you get this U value.
Simon, your
Yes.
sound is dropping out a little bit.
Oh dear.
It literally was just for a few words and then it was back again, but I'm just
sorry about that. I don't know why. Yeah, let me know if it happens again and I'll just repeat myself.
Will do.
Shall I go back to the beginning of this slide?
Yes, let's do that.
Okay. So U values, as it says there, they are used to calculate the thermal transmission of a wall, of a part of the building or an element of the building. They're calculated from the thermal resistance of each part of the build-up. So if it was an old wall, you would use the bricks, the mortar, the plaster, and so on and so forth. Add all those up together and you get the U value. Building regulations require, when you're upgrading something, there are regulations and they are set targets which different elements, the roof, the wall, the floor, and so on, need to achieve. For walls and solid wall buildings, that target varies a little bit. I'm not going to go into all the details now, but it varies because of these risks that are involved, and it's balanced out against different considerations, and it is essentially building specific. So there isn't one target, there is a band in which you should meet things. That's a little bit different from new build and a little bit different from other elements, but for solid wall buildings, particularly internal insulation, there's a degree of a broader band. So U values signify how much, as it says, how much heat leaks through the wall. And if we look at our 9-inch brick wall there at the top, without any insulation, there on the first column, and then highlighted in yellow, we've got the improvements. So using a wood fibre board, one of our boards, 40 millimeters gives you almost 60% thermal improvement. 60, 68, 80, 76, and 100 millimeters, about 80% thermal improvement. As you can see, as the thickness of the insulation goes up, the improvement diminishes. So it's very, very hard after a certain point to go any better. So there are some examples there for slightly thicker walls made from bricks, and also for a typical sort of limestone wall, sandstone would be slightly better. So why is it harder and harder? Why are those results diminishing? Part of the reason is that they don't take into account thermal bridging. So the thick blue line there is internal wall insulation in this case. The dotted line at the bottom is the theoretical result you're going to get by adding more and more insulation. And you can see there's a difference there. And that's because the more you add, the more the disparity between the uninsulated bits of wall, or where the wall can still leak heat from, and you're forever held back by those. If this was a graph showing external insulation, the two lines would be closer together. In our view, and I'll explain a little bit more about this in a moment, a reasonable thickness is in that lozenge shape there. As you can see, after 100 millimeters, it becomes quite difficult, or after a U value there, it becomes quite difficult to gain any significant improvement in terms of thermal performance. Now, risks. So risks with retrofitting insulation are primarily related to moisture, but there can also be fire, and there can be other things as well. But primarily, one of the biggest risks for internal and external insulation is primarily to do with moisture. As I said, external insulation vastly reduce the risks from moisture. But this is to do with the fact that you're changing a building that wasn't designed for insulation to have insulation, and that changes the building physics. It will mean things like you'll need to introduce a different ventilation means of ventilating the building, a better ventilation system. The building regs mention this sort of thing. If it's not done correctly, there are risks. Why is moisture important? Moisture poses risks to the building and also to people living in it. So, water is important, moisture is important for the comfort of general living and health and that sort of thing. High levels are uncomfortable, low levels equally so. High levels, you can think about mold growth and bits of timber within the wall rotting and that sort of thing. Why is this important in solid wall buildings? Well, it's because they're built differently and they are of permeable fabric, as the building regulations describe it. That means that they're breathable, so that moisture is able to equalize from inside the wall to outside the wall. It's not a quite such a free passage depending on the type of material, but moisture does move through the wall. As it cools down, a dew point occurs, and that's where water vapor changes from vapor to liquid water, and that liquid water then potentially becomes a problem. So you can see examples why moisture becomes a problem in buildings. Here's photographs of mouldy plasterboard on cold parts of the wall. So where warm, moisture-laden air meets cold parts of the building, that moisture vapor in the air has condensed. The plasterboard has hung on to that moisture, and it's provided a source for the mold to grow. For mold to grow, you need water and you need a food source. The plasterboard provides the food source, and it also provides the moisture, because it's not very good at releasing moisture. Okay, well, one of the big differences between the sort of products we sell and some of the more synthetic insulations and more gypsum plaster and that sort of thing is how they deal with moisture. And it's really, really important in retrofitting, because moisture is something we want to avoid. So these sort of reasons, you can see there the optimum zone for relative humidity in a house, the green zone in the middle, somewhere 40–50% relative humidity. Too low, you can see, or too high, you get these areas shaded red and increasing risks. Really important things obviously are bacteria, viruses, dust mites. Dust mites contribute towards asthma. So all these things interlinked. So this is all to do with moisture. Yes, you can have a ventilation system, but ventilation systems are often quite difficult to retrofit in older buildings. So it's important to use material that buffers moisture, which the materials I'm talking about, or the materials that we supply, do. So where does moisture come from? Just a quick details of that there. Obviously sleeping, cooking, washing, that sort of thing. But it adds up to, somewhere between 9 to 15 litres a day. That's quite a lot. And it's got to go somewhere. So I've spoken about breathability. Natural materials such as the wood fibre we sell are described as breathable. Breathable, well, everything's breathable, unfortunately. So, trading standards aren't going to tell you enough for describing their products as breathable, because breathability can be measured of all sorts of things. You can measure the breathability of lead. You can measure the breathability of a plastic bag. Neither are described as highly breathable or suitably breathable, but they are nonetheless, they have a breathable or a vapor resistance value, as it's known. Confusingly, it looks a little bit like the U value word, but it's a Greek symbol. It's a mu value, mu. Anyway, this is to do with the vapor diffusion resistance of material. The greater the number, the more resistant it is to water vapor. Wood fibre, sheep's wool, lime are all down at about a mu value of 10 or lower. Concrete, the foil-backed insulation, you'll see, they're up in the hundreds. And lead, which I talked about, was 10,000. So it's not a switch breathability, it's a scale. The other thing I've been sort of talking a lot about, which natural insulations do really well, or some of them, is the moisture buffering effect. So where does that moisture go to from inside the building? Yes, you can have a nice ventilation system, but that doesn't account for all of it, because the wall is that solid wall is a two-way street. It's getting wet from outside and inside. At this time of year, you can imagine lots of wind-driven rain, the wall gets wet. Where does that water go? If there's little opportunity for it to dry out, there's less sunshine to help it evaporate and that sort of thing. So it's really useful to have insulations or insulation systems or products that can deal with moisture without being affected by it. So here we've got 4 different materials really of similar breathability or mu value. Okay, but they deal with moisture in a different way. So mineral wool, stone wool, whatever you want to call it, is as breathable as these other products, but it doesn't deal with moisture very well. If it can buffer almost no moisture, so it's less than a litre per cubic metre of water before something happens. So it can hold on to 1 litre without it affecting the properties of the product, but after that, it no longer can. The boards that we saw in the photograph here, these are high density or rigid wood fibre sheets, wood fibre board. They can hold 50 litres of water per cubic metre. Flexible wood fibre, 30 litres, that's a bit like sheep's wool, and lime plaster, less than 10 litres. So there's a scale here of how different materials interact and deal with moisture, which in turn has a knock-on effect in terms of building health and also occupants' health as well. So I was just going to run through some examples now, which might spur some questions later on, perhaps. These are examples from around the country. I tried to include some local ones as well, of internal and external insulation, or IWI or EWI, if you like. This photograph here, the white building in the middle, that's our external insulation system applied to 2 new passive houses. And on the left-hand side rather, is a internal insulation system applied to an old building. Same architects, same local authority, or housing association rather. So a really important thing before we choose what type of insulation or what type of measure we're going to do, we think about the wall. Is it a solid wall? So solid stone wall, yes. Solid brick wall, yes. But what sort of condition is it in? Is it suitable to insulate? Are there problems with it? You know, are there defects? Is it salting, as in the stone there on the left? Have the bricks badly weathered? And if you add internal insulation to those bricks, they're going to erode even quicker, potentially. Photograph there on the right, someone's added external insulation to a building that was in danger of falling down. They repointed it in cement first as well, just to make sure it really did fall down quickly. And the theory is that external insulation doesn't contribute towards moisture risk within the wall. That's not quite true. You can see a good example of it in this wall here. The timber lintels have rotted because the wall external face of the wall insulation wasn't very breathable. Moisture was being trapped in that wall. When the humidity rose, the timber rotted. There's probably high humidity inside the building, maybe because there wasn't very good ventilation. And look at the results. Anyway, enough of the bad news. So this one might be appropriate to some people who've got timber frames, so not exactly a solid wall, but they can be treated in the same sort of way. So this is an oak frame upper story, a brick building. So it's a Victorian or slightly older building. Brick downstairs, timber frame upstairs. This is lots of really bad, left in a really bad state of repair. Lots of timber repairs, brickwork repairs, new roof. And here we are, some drawings which I've pinched, care of Paul from Concord Conservation, someone we know well. Really, you know, these are well thought through details, following a very careful site visit, and people examine the site, and he's thought about as much as possible how to eliminate those thermal bridges, how to eliminate heat loss through the plinth of the wall, how to detail the little details around windows and openings and things like that. And he's used wood fibre fixed directly to the brickwork downstairs. He's used wood fibre boards directly fixed to the timber upstairs, and sheepswool insulation between the timber studs. Now, all of this is a breathable system, so no moisture is stuck in that timber frame, so it won't rot. The insulation over the top cuts the thermal bridges, and then it's going to be rendered. Note the detail around the plinth on the brickwork. He's sort of everything here. Some slightly before the finish photographs of how the roof was extended slightly to cope with the new thickness of insulation, ventilation grille, and the finished job. This one's about, I think this is 12 years ago or more. And they've used a lime render that we make that's self-coloured, so they don't have to paint it. So if you think back to the nice Germanic brick, half rendered building at the beginning, then you wouldn't necessarily know this was insulated and a really thermally efficient building. Right, sorry if I can speak. Internal insulation. We recommend that our internal insulation system is fitted directly to the solid wall, so you haven't got a gap or cavity. We've looked into this thoroughly over the last 10 years, researched it, as others have, and it works better if you've got a solid wall to do it as shown in these pictures here. So you have a levelling plaster made from lime. This allows moisture to go through the wall. Then the boards are fitted. So photograph there on the left, boards are fitted to the wall, the levelling plaster, taking care in the middle there to try and include insulation right across the wall. When you're doing internal insulation, you need to kind of you don't want to leave any bits uninsulated. And then over the top is the finishing plaster that we make. So there's 4 components in essence: levelling plaster, the lime-based adhesive for the boards, and then we have a 1-coat lime plaster that goes over the top of the wood fibre boards. And it's all solid on the walls. It works really well because it's breathable. It buffers that moisture, controlling the indoor climate, and it locks up carbon because of the boards. And chosen here by an architect in London for his Victorian house retrofit and his new extension, and he did it on all the walls, ceilings, and left it unpainted because he liked the look. Just another project there showing the details around the windows. Really important to cut those thermal bridges. Right, this is more of a this is North Shropshire project, more of a true external insulation retrofit using 160mm thick boards. So wood fibre boards can come in different thicknesses from 40 up to over 200mm. Here on the left, there's a starter track where the system starts. It's installed in a very similar way to other systems in reality. It's just the materials are chosen are different. Cutting the boards, fixing the boards, mechanical fixing, holding the board to the wall. Some important details here, can't quite see it on the left-hand side. The eaves have been extended, the windows have been renewed and moved forward to make the most of the thick layer of insulation, and then it's plastered and rendered using one of our lime-based renders. And it ends up looking something a bit like that. And that's me, finished.
Excellent. Thanks, Simon. That was excellent. A really good talk. Yeah, brilliant. Thank you. So we've also got quite a few questions that it has inspired. If anyone has thought of anything else, please continue to drop them in the chat and we will pick them up. And I shall hand over to Tony, who's going to facilitate the Q&A.
Right, thank you very much, Simon. Yes, and thanks everyone for all your questions. I've got quite a few already. I'm going to try and nail 2 or 3 sort of immediately, Simon.
Yep.
Just to start with what you haven't mentioned. So my mum lives in a 1960s cavity brick and block house.
Yeah.
Am I right? I'm going to say it doesn't breathe. You're going to tell me, well, it does, but possibly not very much. Where are we with that and modern construction? So obviously you've talked an awful lot about solid wall houses.
Yeah.
Are we saying that wood fiber is appropriate for those, or
yeah, it absolutely is. You know, we've got people building super insulated passive houses using wood fiber, you know, who use it. So the examples I've given are to do with its technical properties around moisture in older buildings, which are, I think, really, really important. In newer, sort of new build, and the focus changes slightly more on sustainability of the products and that side of it. And so the passive houses, they wanted a really green build that was carbon neutral as well as passive house. So you kind of got 2 ends of the spectrum, really. You've got really high tech passive houses right back to buildings that might be a few hundred years old. But it's appropriate to all. Perhaps if you go back to that wheel of the 8 properties of insulation, you know, we think some of these natural insulations cover a wide range of those, and some of those are important to different people.
Right, okay. So I appreciate. So yes, there are other reasons for using it, but yeah, just to be clear about the breathability, strictly speaking, a cavity wall built of block and brick and cement, it doesn't actually need the breathability. Probably,
yeah. It's not like it's a completely barrier to moisture, but because of the way it's constructed, it will be of lesser importance that the materials. I think there will be some benefit, but it won't be quite as beneficial, or it won't be as imperative to use them as it would be in a solid wall.
Okay, right. So the solid wall property that I'm sitting in, which is built in 1872, a number of people have been asking about this. So it's got masonry paint on the outside. In some circumstances, a similar property could have cement render on it. On the internal finishes, it's got gypsum plaster.
Yeah.
So it's a breathable solid wall, but the ability of the building to breathe has been compromised. So what do we do there? Do we need to get rid of all the stuff?
Okay. So it becomes, this is why there's some there's a banding in the BIM regs and so forth, because they recognize that every building's different. In this case, in theory, the masonry paint is a vapor barrier and it's in the wrong place. So whatever insulation you add on the inside, be it product from us or from, you know, a non-breathable insulation, if you like, from somewhere else, that masonry paint is always going to be a problem with internal wall insulation. So if it's older masonry paint, it's perhaps become porous and it may be less of an issue. But it's same goes with the cement, really. So ideally, you take it off, but that's not always possible. It's always difficult to give one answer to this because each house is different. But in general, whatever insulation you use internally, those 3 elements, the gypsum plaster, the cement, and the masonry paint, will potentially give problems because of their lack of, or their high vapor resistance. If it was external insulation, they are probably okay. Although the masonry paint would ideally go. But that is something we check. So on each job that we get like that, we would try and run a little calculation to see whether it's going to be a problem or not, and whether it should come off. But generally speaking, they are problematic.
Right. Okay. Thank you. Just to press you on the external wall insulation, Anna asked a question, and can you have external wall insulation on top of render externally? Yeah. Where the render isn't smooth? A question for, I don't suppose that render is ever going to be lime. It would always inevitably be cement based, would it?
Yeah. So that yes, that's doable. Say for instance, it's pebble dash. Maybe it's unpainted pebble dash as an example. Okay, because there's quite a lot of that about. Then yes, you can put external insulation over the top of that. There is on the back. So most external insulation systems, ours included, there is like a supplementary adhesive, if you like, which goes on the back of the board, around the perimeter of the board. That does two things. It helps hold the board to the wall, but it also stops air movement around the back, and it levels the board up on the wall slightly. So it's possible, yes.
Okay, great. Thank you. Sorry, the other question from Anna was, is it possible, I'm not quite sure how this is going to work, but is it possible to have external wall insulation on the top floor of a building, but not below? Presumably you need something to support it.
Oh, okay. Yeah, we have this question quite often. Can I external insulate, or can I insulate parts of my building? And the answer is yes, but if you think about it, so what very often it might be that a building in, say, in a conservation area, may not be a listed building, but a building in a conservation area, and the facade, the front of the building, don't want to change it, or maybe part of the front of the building or the side of the building is already rendered, and they want to insulate the back or the side of the building. That's possible, but then if you don't insulate the front, or perhaps you insulate it internally, it's not as an efficient job. If you think back to that sort of tea cozy effect, if you're only doing part of the building, you're losing out. Really, you're not making the most of it. So yes, possible, but is it what are you benefiting? Really.
Okay. I've got a more technical question about carbon credits. Okay. You can help with this. Dan wants to know, can carbon credits be claimed for biogenic insulation products to reduce their relative cost?
Oh, that's a good question.
You're allowed to say I don't know.
Yeah, I think I might say I don't know at the moment. We have an environmental product declaration for the boards. They lock up, I think, 235 kilograms a cubic meter of CO2. I don't know, actually. If you find out, can you let me know?
Okay.
I could try and find that out for you, but off the top of my head, I don't know is the actual answer. So, it's something I could look into.
Okay, we have a couple of questions from Roy. One was to do with the research done by SPAB and by Historic England.
Right.
The U values you've been quoting, do they reflect that research?
They do, yes, they do. So if you go back to the slide, I won't show it, but it'll take a while to find it. But if you go back to the slide where I showed the uninsulated wall and its starting U value, that was taken from both the BRE and the SPAB's research, and where they found that computer modelling, surprise, surprise, isn't always that accurate. So those figures are, yes, generally speaking, the starting point for the walls are the slightly more realistic figures that most people are using now.
Right.
If that answers that question.
Okay, yeah, thank you. So I should point out SPAB is the, what is it, Society for the Preservation of Ancient Buildings, who are very interested in this sort of thing for obvious reasons. Roy was also asking a question about dry rot, which is quite a lengthy one, but does well, does the wood fibre encourage dry rot? Is there a danger of setting up dry rot by putting wood fibre against an existing external wall in traditional buildings which hold a fairly high degree of moisture? The wood fibre acting as a food source?
No, because actually the wood fibre itself, so for insects or anything like that, it has been, so yes, it's wood, it's made from wood, but it's a manufactured product. It has been, it has been remanufacturing something, and the food source has been removed effectively. So it's not there. So it's an inert material effectively. So it doesn't provide a source for insects or anything else. So that shouldn't be a problem.
Okay, thank you. Nobody's actually asked a question about cost. Well, although Anna has just pointed out there is a place for other forms of insulation, particularly use recycled glass, for instance, being turned into fiberglass, which are, are cost effective. I should point out, Anna, that's fine, but this talk is specifically about natural materials, so that's why we're not really talking about the others. But can you help us with cost, Simon?
Yeah, I'm not up to speed with it exactly, but because particularly the synthetic installations have been rising wildly. I mean, in last year, some of the PIR manufacturers, their costs, the prices went up by more than 40%, which is huge in 1 year, and they did the same sort of the year before. Their costs are going up at a quicker rate than the natural insulation, generally speaking, so it is becoming more competitive. And over time, as people start factoring the cost of carbon, I think you'll see that actually it will swap places before very long. In other European countries, particularly countries like France, they've made it mandatory to include materials like this in all construction to reduce the carbon footprint of their built environment.
Right.
And they effectively push the price up of the synthetic materials. So it won't be long. It will come where the parity is reached, and then they overtake it, I think.
Right, that's interesting. Okay, I've got a question for Polly, which is kind of related. Some rooms in the house have been insulated using synthetic board. They want to use natural materials in the remaining rooms. Is that going to cause a problem? Presumably, if you're not putting the natural material over the top of the synthetic, you're putting it in another location. Is that okay?
Yeah, I think that's right. I think mixing and matching on the same wall is probably a no-no. But I'm assuming this is internal insulation. Then a different room is a different room. I mean, we were involved in studies where people, Historic England did that at the flax mill. And it didn't fall down or go wrong. They just got different results on different parts of the wall. Okay.
Question. So when we go for external wall insulation, we've got the T-cozy all around the property. We know that it's ideal to move the windows out to the insulation envelope. How does it support the weight?
Okay, so actually, I'd have to show you that photograph again, but actually there was a supporting brackets made or timbers that hold the window. So the insulation doesn't actually. It's the sort of framework in place to hold the window. And the reason we do that, or reason people do that, is because that you get a more effective result. The reveals to windows externally off if the windows stay in their original position and you add insulation on the outside, there's a gap there between the insulation and the window. You can't do that with anything other than quite a slender piece of insulation. That makes that more of a thermal bridge than the rest of the wall.
Yeah.
So that's the reason they move forward to the back of the main. You know, if you're adding 100 millimeters of insulation or 200, try and bring the window forward. If you're having a new window, it makes it more effective.
Okay. Questions you might have heard before. Does wood fiber attract moths or woodworm?
No.
You have those sort of problems?
Neither. No. You know, the wood fiber has been in use for over 100 years. We've used it in this country for 60 years on timber frame buildings. And a few years ago, went to a cult house near Bridge North that was insulated very poorly, but it was insulated with wood fiber. There's nothing wrong with it. It was just way too thin. So no is the answer to that, unaffected by either.
Okay. Right, apologies. Right, there's an interesting question from Sally. How do you know if plaster is lime based or not?
Oh, okay.
I mean, we're talking about obviously dry plaster in one's house.
Yeah, exactly. Okay, so on our webpage under insulate, actually it's on the internal insulation page, insulate internally, there's a site guide about site assessment. And in there's a little written guide to figure out what you've got. Have you got a solid wall? Have you got lime plaster? Have you got cement? A good way of basically what it says, there's a few different ways. Chip a bit off if you can. Drop it in a bit of acid. It could be vinegar. If it readily dissolves, it's lime. If it takes a very long time to dissolve, it's probably cement. And if it doesn't dissolve at all, it's probably gypsum. Flicking water on it is another way to see if it's breathable. Porous. You know, there's a few different ways like that. Color. Lime plaster is generally white. Gypsum sometimes might be white. Some often pink. You know, these little clues. If in doubt, get in touch with us. We'll help you.
Okay, great. So another general question about wood fiber, along with the insects, does it create a fire risk?
No, we've got fire test certificate for all of our systems. It's second only to those which use mineral insulation. So one of the advantages of mineral wool or mineral-based insulations, not the synthetic plastic type stuff, but the mineral wool, is that they are class A, which means that, you know, class A is the highest you get. Ours are class B. So they are, the system is very effective against no flaming droplets, no smoke production, class B. So it's as good as you can get, really.
Okay, great.
Apart from class A, sorry. As good as you get from class A, sorry.
Almost as good as you can get. Okay.
Yeah.
Little bit of a technical question from Nigel. External wall insulation means the thermal mass will be much higher, leading to a slower warming time. Is there any modelling of this available to investigate this?
Oh, I'm sure someone has done it. I haven't, or we haven't got that information. It's someone like the ASBP who I mentioned earlier. They're the people trying to speak to, you know, they've got sort of research stuff on there and things like that on there. They're the people I would start with. And I bet you there is somewhere, but I can't name it, I'm afraid. Sorry. There might be,
Okay.
yeah, sorry, I can't think of anyone other than ASBP or STUBA or something like that.
Okay. Got another question about biochar. Do you use biochar in any of your products?
No. No, we don't. I'm afraid there's exciting products coming along all the time, you know. So people have been making insulation out of all sorts of things more recently, or trying to. So it's exciting time for all sorts of construction products, but no, we haven't, I'm afraid.
Right. Okay. In a stone-built open barn, we want to significantly increase the insulation of the new wood-clad section. Is this of any help if not insulating the entire wall? The main walls are 50-centimeter rubble stone.
Yeah, that should be doable. I can't quite picture it exactly.
Sort of a part of a tea cozy rather than a whole tea cozy.
Yeah. Sounds like it should be possible. Any of these questions or anything, people are welcome to send us pictures or diagrams or drawings of stuff with make it warmer type requests, and we can see how it fits in.
Where to? Is it Simon at Lime Green?
Yeah, basically Simon at lime-green.co.uk, or to just, you know, follow the one on the website and contact us, and we're more than happy to you know, spend a bit of time thinking about it, and we'll, you know, if it's not possible, we'll say. There's no point in us saying yes to everything, because it, you know, will only disappoint people. But that sounds like something which is there's a yes answer to, without a doubt. I you know, sometimes these things need a little bit of thinking about before you.
No, you're doing very great, very well. Thinking on your feet. We are just about running out of time. If anybody's got any burning issues, do pop them in the chat right now. Could you just remind us of the testing method for plaster, if it's lime or cement or gypsum?
Oh yeah, okay. So good one is get a bit of acid. It doesn't have to be particularly strong acid. Chip a bit off. If it readily dissolves in the acid, then it's white, then in colour, then you've most likely got lime. If it doesn't dissolve, it's probably gypsum. If it slowly dissolves, it could be cement or something with a pinch of lime in it. So quick dissolving and bubbles and white in colour, that's probably lime. And vinegar will probably do, is just vinegar or another acid a bit like that, that would do.
Okay. Interesting questions have popped up about having a floor insulated with Kingspan and leaving it alone, or should we remove it because it isn't breathable? We haven't talked about floors. Presumably, we don't really worry about them.
I wouldn't touch about. I wouldn't bother with it. I know some people are interested in breathable floors, or so-called breathable floors, and they're often used in very old or special buildings, partly because they're sort of, the materials are heritage appropriate. But in this situation, you're not going to dry the ground out. I think there's better ways and better places to spend your money. I think I'd leave it as it is, unless it's poorly insulated. You know, if it's only a very thin layer, then that might be a different thing. But your floors are quite expensive.
Disruptive to dig up.
I'd perhaps go for some cheaper wins, so to speak, in terms of insulating other things before I worried about that. If that's helpful.
Okay, got a comment here from George. This could be helpful to everyone. It's about £10 for an infrared thermometer gun. It points a red spot to the wall and tells you the temperature, especially in cold weather like now. I found most leakage in the top foot of my walls because the walls are thinner there due to the slope of the roof.
I think it's a really good point. We've got something similar, a little cheap infrared camera, and it's fascinating to see actually where the problems are. So my so my stone wall, so stone wall of my house, or part of my house is stone wall. I plastered it 14 years ago with insulating plaster we make. That was quite good, but where it was not very good was round the windowsills and round the windows, basically the reveals, the bits I should have known better about. So that's where the cold was coming from. So it's really, yeah, I agree with that. It's a really good suggestion, and means you can be if you're on a limited budget or whatever have you, or disruption is going to be too great, you can really figure out where the problems are, and probably tackle those for not a lot, some of them anyway.
Okay, I think we need to wrap it up just about. We've got a very good question from Emma, who's asking about the durability of the product. Say we're talking about wood fiber being used for external wall insulation. What's the longest standing building that has external insulation on it? How long is it going to last? What sort of maintenance are we looking at?
Yeah, okay. Yeah, that's a good question. So in relation to our products, this was external insulation, wasn't it?
Yeah.
We have...
Well, internal presumably looks after itself and lasts for ages.
Yeah, by and large, yes. You think internal, things like impact resistance. Same goes for outside, but sort of, does it get physically damaged and that sort of thing? External, the same. So all external insulation, as I said in the talk, should go through testing. It's quite rigorous, and it's one of the few building products that has actual durability testing. And to pass the test, you need to pass a 25-year accelerated weather chamber test, and after which the render must stay bonded to the wall, no cracks, no falling off. It has to come out as good as it went in, essentially. And because of that, we would say, or we didn't used to say, but our third-party assessment said it's good for 30 years with maintenance. That maintenance would mean repairing damage where it got, say someone, I don't know, backed into it with a car or something like that, or whatever, or dented it, or somehow, you have to repair that, and then you might need to paint it. It might get dirty in 25, 30 years, but that's the sort of, at least, that's the minimum, 25, 30 years as a minimum, with maintenance, things like painting, cleaning, repairing damages, that sort of thing, providing it's well installed. So it's got to be well. So I showed you the Paul Mallion one, that Conquer conservation project of the half timber, half brick. That's now 15 years old. It's a wildlife conservation centre. He goes back on a annual visit each year or each 2 years or something, and updates us on its thing, and it's absolutely fine. It's as it was before. So okay, yeah, should be a long time.
Right. Okay. But the oldest that we know are sort of 15, 18 years old.
Yeah, of ours, but external wall insulation in general, using all materials, it's probably oldest in the country are more than double that. There will be external insulation from some of our materials suppliers in other parts of Europe will be 30, 40 years old using wood fibre.
Okay, great. I suppose the point to make there is it's wood fibre attached to the external surface of the building, but then it's protected by lime render and paint. So it's and
that's a really important
look
bit.
After the lime render and repaint.
Exactly.
Right, we're going to have to draw it to a close there. Thank you everyone for all your questions. Well done, Simon. I'm going to hand back to Gemma to wrap things up, but I did want to point out an interesting webinar to pick up on that is similar to this one. We've got it's repairing heritage buildings and retrofit to heritage buildings, which will be in the middle of March, March the 17th, I think, being given by some Herefordshire architects. So that might even be of interest to you, Simon. You're very welcome to join us if you like.
Thank you.
And an awful lot of people who are looking at retrofit are interested in solar panels for obvious reasons. And we're still yet to nail down a date, but we think that'll be towards the end of February. We're going to have a solar and battery storage webinar. So that should be very useful. So do come along to that. Thanks to Simon. I'll hand over to Jem.
Yes, thank you very much. So as Tony just said, we've got those events coming up. I will share details of those with you all. Please feel free to sign up and come along and share them with others as well. It would be good to see as many people as we can on those events. I'll also circulate the recording of this webinar, so you can go back over it if you'd like. There's obviously a lot of information in the presentation and in the Q&A as well. So thanks again to all of you for your really useful questions, and for Simon for thinking on his feet to respond to them. I'll share Simon's contact details so you can take him up on his very kind offer of technical advice for your specific homes. And I'll also get you details of how to apply to Future Ready Homes in all areas if you would like to apply for a free survey and retrofit plan for your property. So that just leaves me to say thank you. Thank you for joining us for an hour and a half on this Monday, and I will see you next time.